Thank you for your patience. First of all, can you hear me correctly? Yeah, cool. That's nice. I would like to thank the organizer for this conference. You are a lot, so thank you very much to be here. Just a question before we start to wake you up. Who already faced a CAPTCHA? Raise your hand. I think most of you, okay. Who already did it when doing some web scraping? No? No one's doing web scrapings? No one tried to get a CAPTCHA? Okay, some of you, cool. So my name is Fabien Vauchelles. I've been deeply passionate about web scraping for years. My enthusiasm led me to the fascinating world of proxy and antibot system. So I work at Wireman, an amazing company specializing in revenue management within transportation industry. And our work at Wireman involves handling millions of prices on a daily basis, which requires substantial investment in web scraping technologies. Our setup for data collection is pretty big, mainly built on open source. I'm also the creator of Scrapoxy. So what is Scrapoxy? Scrapoxy is a free and open source software that I developed for 8 years. It allows you to manage and route traffic through cloud providers. It supports major cloud providers such as AWS, GCP, OVH, and also cloud services like Bright Data, Raybyte, IPURL, and many others. So since I started version 4 in 2024, over 200 users have installed Scrapoxy, exchanged 100 terabytes of data, and used 1 billion proxies. Before we dive into our discussion, I'd like to share with you a little story. So a decade ago, I found myself within the conversations who work in the HR industry. This was also a time where AI and NLP were just at the beginnings. During our conversation, we stumbled upon an idea. It is always challenging to find candidates in the IT industry. So we wonder, what if we could predict if someone might leave their job within the next 2 or 3 months? So we could reach out to them and offer them exciting job opportunities. It's unlike a brilliant concept on papers, but as you probably know, to train your machine learning algorithm, you need large amount of data. And disclaimers, it works. So to do that, profiles. We need a lot of profiles, millions of profiles. We thought, okay, let's go and gather them. The real challenge came when I tried to collect hundreds or even thousands of profiles. I hit a wall. I was new to web scrapings. So I checked on Stack Overflow as usual, and I get some solutions. Hey guys, use proxy. So, okay, but proxy were very expensive at these times. So my idea was to buy a virtual machine on Amazon, a VPS, and install a Squid proxy and get a fresh IP address. It worked a little bit, but I faced the same problem. So how can I get many fresh new IP addresses? The answer came into the form of a basic script. By destroying, creating, and installing new VM automatically, the IP address will change, and you can scale it. So it was the Scrapoxy project. But my journey had just begun, in fact. Using VM from cloud providers doesn't prevent you from being blocked. And at this point of time, there were some things that I didn't know. Something known as the Turing test. So let me share with you another examples. So when we purchase a flight ticket to come to VDTRIESTE, it seems like, hey, I'm a human living in Paris, and I'm so excited to be here. I will buy a round-trip ticket during the evening using Safari and Mac, and I use the fiber connections. So these interactions is a natural and organic behaviors. But when it comes to web scrapings, it often takes different forms. It's more, hey, I'm Scrappy, living in a data center in Ireland, and I don't be interested to travel anywhere. So my goal is to retrieve thousands of prices from many airlines. I'm accessing to data with a deep link at 2 a.m. with a Python library within my Dockers. My internet provider is AWS, and I love to randomize all my parameters to simulate humans. So, thank you very much. Honestly, these behaviors doesn't seem to be organic. And the website understands that, and the antibot too. So you see, they conduct Turing tests on your behalf. So the question is, how do antibot systems assess us? They meticulously check our browser stack, analyzing each signals. Starting from our IP address, they know where we are coming from. The protocol header reveals details about our operating systems, the browser, the versions, and they execute JavaScript to get our system and browser configurations. Also, they track on navigation patterns, like the sequence of web pages and even sequence of events, such as mouse movements. And of course, they will cross-check all the signals to validate consistency. So now let's dive into each layer of the browser stack. You see that it will be cool. So the initial layer is the IP address layers. It is the very first piece of information a website obtains when we establish connections. An IP address is a gold mine of informations. Are we connecting from an internet box? Are we connecting from a mobile device? Are we connecting from a data center? For instance, if we are purchasing a ticket to Paris, from Paris to New York, is our connection originating from India? Is there a consistency, such as having a US IP address and a browser time zone based in Western Europe? It could be some red flags, and all these signals flag you. Moving to the second layers, let's understand the power of protocol headers. So there is 3 protocol headers: TCP/IP, TLS, and HTTP2. First up is the TCP protocols. The RFC describes how operating systems should implement the TCP protocols. But in practice, the implementation often vary from one operating system to another, and not only, even between the different versions of one operating systems. So we can detect Windows, the different versions of Linux, whatever. By examining the TCP header statistically, it is possible to understand which operating system is sending the packets. Also, we can look after the TLS protocols. So you all know the TLS protocol is an encryption protocol on top of the TCP protocol, and it's used everywhere. Okay. You know that, yes? Yeah, cool. So here is an overview of how it works. So when a browser wants to establish a secure connections, it initiates a negotiation with the website. During this process, the browser uses the handshake protocols, and the browsers send a client hello message. So this message contains a list of supported encryption algorithms such as RSA, DSA, and a lot of options. It is called the cipher suite. And the server selects the most secure and compatible protocol, and they establish a connection with a key exchange. Okay. This is where the magic unfolds. Each browser version has its unique cipher suite and options. This leads to the creation of a TLS fingerprint. So it is called the JS3 fingerprint. It was invented by Salesforce. With this fingerprint, the server can identify which library or browser it is. So is it Chrome, is it Firefox, is it Edge, whatever? Is it a Go library? Is it a Python library? Is it a Node.js library? So it's automations. And third up is the HTTP2 protocols. HTTP2 receives to TCP headers. And by examining statistically, it's possible to deduce which operating browser send the packets because there is variation settings, priority flags, field order, whatever. So now I think you know where I'm heading with this, okay? Imagine this. We claim to be a Firefox browser on Windows, so that's cool. But the browser stack suggests that we are coming from Linux with Chrome. It's a red flag. And it could lead to a ban. And of course, it doesn't end here. We can also look at the HTTP protocols. We can fingerprint the HTTP headers. Here is a small code of a well-known Antibot system for Node.js server. I won't say the names. The code is public on the internet. It is just 4 lines of code, but it's bulletproof. This tiny little function gets the list and order of headers. That's because when we are developing a scraper or spiders, we try to reduce the number of headers to the bare minimum to keep a simple and maintainable code. Okay, that's cool. But when you read this function, you understand that all headers are essentials. Even they are not crucial for the API. They are vital for the fingerprint process. And this kind of function can block most of the spiders in the world. And of course, all browsers can execute JavaScript. So that's cool. It's truly astonishing how much information they can extract from JavaScript. They can get detail like your time zone, or GPU model, or GPU fingerprint, so they can cross-check with the GPU models. They can get also the number of speakers, the number of speakers. They can get the microphone status, they can get the webcam status, the battery level, so they can know if we are using a smartphone or laptop. They can also know the list of fonts installed, the list of extension and plugin installed. They can know if we have a block. They can know if our real address, if we are linking that with a web RTC link. They can know the screen size, whatever. You're afraid, huh? Yeah, that's cool. And if you are using Android, they can know far more information. They can know if you are using Android debug, so you're doing reverse engineering. They can also know if your device architectures. So if you are using ARM, that's okay. But if you are using Intel, it's because most emulators use Intel architectures. So you are also doing reverse engineering. They can know also the Android version, the smartphone model, and also on the latest Android version, a unique install ID of Android. So they can barely track you everywhere. And of course, it's not finished. The last layer involves to track how we act on the website. So Antibot system observes the sequence of web page we visit. Do we initiate our journey with a search query, or do we access to data with a direct deep link? We also check if we are executing JavaScript, loading CSS, or only fetching HTML. They also track the timing of our actions, the interval between web pages. It's like a smart rate limit systems. They also track the delay between mouse click, and they check also mouse movements. You know, humans tend to move the mouse cursor in a natural, fluid manner, resembling to a basic, but bots use a straight line movements. So they track that during times. And all these informations are transmitted to the web server at intervals. That's why sometimes you navigate smoothly a website, you get 1, 2, 3, 4 page, you get your information, and suddenly you get a CAPTCHA. It's because your reputation score gradually reduces over time and go below threshold. So the antibots say, okay, should be about, let's send the CAPTCHA or perhaps directly block the page. Okay. And all the signals are combined together to generate binary classification scores. So algorithms blend everything and use machine learning techniques to rate browser sessions. And to improve and adapt over time, they use reinforcement learnings. So like algorithm like CatBoost, they are using that. It's very efficient. Yeah, so if we examine the previous stack, it becomes evident that trying to outsmart a Turing test is a huge challenge. But if you think about that, there is always some vulnerability. And there is one, and this weakness is known as false positive. So let me show another examples. A couple of months, I tried to purchase some train ticket online. So I was connecting with my laptop. I'm not doing web scraping with that, not with my own IP address, okay. But after selecting, taking time to get my ticket, going to the payment, hey, the website blocked me with a message. You're a bot. Honestly, I was surprised and I didn't understand. It was, in fact, because I'm using Linux. So they are mostly blocking Linux. We can say, woo! Okay. Thank you for supporting me. But in fact, no issue. I just switched to a competitor website. It was a false positive. And it happens all the time. Websites raise their security too high and they must lower it to get their customer accessing to the websites. And if you run a business, false positives are something that you want to avoid at all costs. And Antibot system must adapt. So if you already did a little bit of data science, you know the tricks. So to do that, to adapt over time, there is two approaches. The first one is if you want to use all available signals, so there is thousands of signals to track, you require a massive volume of data for each signals, clean record for each signals correctly tagged. Okay. So that's very too challenging, too expensive. It's very hard to get that. So what you're doing is you focus on the most effective signals. So you reduce the number of signals. And furthermore, you must understand that some signals are very difficult to get all the protocol headers, protocol signal on TCP like that, because you must be root on the machine and it's difficult on Kubernetes, so it's very difficult to access some signals. And nowadays, commercial solutions track between 100 and 200 signals, not 100. So I'm lucky. So they rely on IP address, HTTP headers, JavaScript execution, and also behavior. And now they start to track TLS Fingerprint. Now our objective is to understand which commercial solution is used on the website to go deeper. And to do that, we can use Wapalizer. Who know Wapalizers? Some of you, yeah. So it's an amazing extension which gives you all the technology of the website, especially the security technology. And you can confirm that with, it's not loading. Let me check. Yeah, okay. So here it's saying the technology inside, okay. And you can confirm this information by opening the Chrome Dev Tools. And if you are looking on the network inspector, there is some creepy request. Most time it's Antibot system, and if you go deep, you will get some cookie and some stuff. And it's encrypted, so yes, you have these Antibot systems. And if you are using Android, it's far more easier. You can use interceptor proxies such as Scrapoxy, HTTP Toolkit, Burp Suite. And furthermore, when you deal with Antibot system, it is easier to analyze Android applications because you can decompile the Java application with JDX and perform some live injections, so modifying the function behaviors live using Frida. And this can be very helpful to understand how some fields are generated, especially some ID in requests, which most of the time pop up from nowhere. So we can use this kind of stuff. So now I would like to share with you the architecture of Antibot system, so how they play together. So we have the browser, the website, and the Antibot. So when we connect to website, our browser also connect to the Antibot URL. Sometimes the Antibot URL is hosted on the website, sometimes it's hosted on a dedicated servers. First, with JavaScript, the website gathers a lot of data about our configurations, everything. So it's the Antibot code obfuscated on the browsers. This information are encrypted and sent to the Antibot URL. In return, the Antibot will issue tokens, which mostly is a cookie, and this process is repeated over time to monitor our sessions. So now when we try to connect to the website, we send our request to the website and we add also this token. And it's very easy for the website now to check our reputation. It initiates a server-to-server connection to the Antibot system and retrieve our reputation score. And based on this score, the website grant or denied us access. So that's very easy. So now let's check how Antibot secure its payloads. There are many methods for payload encryptions, from base64 encoding to asymmetric encryptions. I will focus on the most advanced one here, so asymmetric encryptions. So first, the obfuscated Antibot code on the browser gather a lot of data about browser configuration, etc. the events. The data is structured to a JSON with internal key, so it makes it more challenging to understand what the key is, the purpose of the key. Second, the obfuscated code uses RSA encryptions. So the public key is added to the Antibot code on the browser in an obfuscated way. So it's very difficult to collect this key. And the encrypted payload is sent to the Antibot through post request. Now, the server decrypts the cipher using its private key. Since the server holds the private key exclusively, it is impossible to decrypt the intercepted payload. So, as we saw, it is difficult to handle an Antibot systems. So we need a methodology for constructing a scrapers, because website and protection evolve quickly. Additionally, it is important to note that not all websites have the same level of protections. Some websites have no protection, some websites have small protections, some websites have difficult protections. And using the same approach for every website can become costly and time-consuming. So we need an incremental methodology to adjust our strategy. I will share a generic one. So it's a possible methodology. So imagine that you already have your scraper. You use Scrappy, the famous Python framework. Okay, you code everything that's working, but after 100 requests, it's very difficult to bypass the Antibot. So the first thing that you can do is to tune the parameter. You can adjust the number of concurrent requests, the delay between requests. You can adjust also the user agent and the HTTP header to make it consistent. Sometimes you say on the user agent that, hey, I'm Windows, let me pass. But the other header say, yeah, we are in fact from Linux. So it's not very consistent. You can also adjust the TLS version, the payload, the order of requests, whatever. But at some point of time, you will be blocked because you will use only one IP address, which is your laptop or a web server. So we need to introduce the concept of proxy. What is a proxy? A proxy is a system relaying the request to the website. So for the website, instead of seeing millions of requests sending from one IP address, you will see a lot of requests sending from a lot of IP address. So it's okay, we can go with that. There is plenty type of proxy. There is data center proxy and so more. So data center proxy is VMs that you install on data centers to relay the traffic. You can use Scrapoxy to orchestrate your strategy. But at some point of time, you can be blocked. You are not acting like a browser. So we need to introduce the headless browser concept. So what is a headless browser? It's a browser simply run inside the Docker without a display. Okay, there is a lot of framework to do that. Most of the time is the test end-to-end framework like Selenium, Puppeteer, Playwright. You can use them. There is a lot of extension to skip the JavaScript fingerprint. But yeah, if you are using that, on most of the website you're blocked. So we need to introduce more advanced proxy. There is ISP proxy, residential proxy, mobile proxy, hardware proxy, a lot of different type of proxy. So ISP proxy is like data center proxy. They run on data centers, but they are not using the IP address of the data center. Instead, they run the IP address from a mobile carrier, internet box provider, whatever. You can rent this kind of IP range. It's possible. You can use also residential proxy. So it's user sharing their real mobile device, their real laptop for money. You can do that, get some money sharing your device. So you get the IP address from a real user, perhaps just he was just on the social network 10 minutes ago, so the IP address is very clean. And you can use also mobile proxy. So its providers, they have hundreds or thousands of 4G key in front of the antenna, and it's very clean IP address. But of course, you can do your own by using hardware proxy. So you buy the material and you do your own 4G key mobiles proxies. And sometimes at this point of time, it's not working too. It's because automation is detected. I didn't tell you, but you can detect Selenium, Puppeteer, Playwright. They let a lot of insight with JavaScript. So it's time to move to more advanced framework, which is Helpful Browser. So you build your own stack these times. There is commercial solution for that, but you can use open source library. And if everything is not working, you can use what we call a non-broker API. So for a lot of money, they will do all the previous steps for you. You can directly jump to this step if you want to get the data quickly, but it's commercial solutions. And sometimes you need to solve some CAPTCHA. There is AI CAPTCHA solver, so they are solving the reCAPTCHA, the Google Enterprise V3 reCAPTCHA is very hard CAPTCHA in 2 seconds, so it's very easy to see that moving with AIs. You can use that, and please don't use human form for that. So if we translate previous methodology now into an architecture schema, it will be the following ones. So first, we build a scraper. It collects data all over the world. Okay? It's okay for you from now? Yeah? You're not sleeping? No, perfect. Second, okay, we are growing, so we need a better organizations. So we set up a place to store all the collected data and also the URL frontier. The URL frontier is a list of URLs that you already visited and the list of URLs that you need to visit. So this means we introduce 2 important components, a database and an orchestrator. And in addition, we often use a broker to distribute the tasks, such as RabbitMQ. And second, realize that using just one IP address is not enough. So we need to add some proxy. We add the Scrapoxy layer to manage all these layers of this proxy. So it's cool because it comes by default with cloud providers supported like GCP, AWS. And guess what? All these cloud providers give you free massive credit for startup. So you can very quickly start your own private proxy pool. But sometimes, even with new IP addresses, things don't go smoothly. So we add different type of proxy, like ISP proxy, mobile proxy, residential proxy, whatever. And of course, Scrapoxy can handle everything. And we also learned that we need to execute JavaScript, and we need to introduce headless browsers. But rather adding one single browser, we can add many browsers like Chrome, Edge, Firefox, whatever, on many operating systems, Windows, Linux, whatever. And this is the most tricky part, because there is no free open source tool to do that. So you need to write it out on your own. Okay. So now, with this kind of infrastructure, you are able to collect the web. You're good now? Yeah? Let's go to the second part. because I didn't disclose you the whole truth. In fact, the web is divided in two parts. So we have 80% of the website driving half of the internet traffic. The remaining 20% drives the other half. And here, we are speaking about major e-commerce websites, social platforms, whatever. Because these websites drive a lot of traffic, they use the most advanced protections. So our generic previous approach cannot fully work, and we will have very low success rate. So this time we need to monitor precisely which signals antibots use and try to emulate them. So if you remember the previous antibot architectures, the signals are embedded in the payload. It's inside the payload. Okay. But the payload is encrypted, so it's impossible to intercept and detect what's inside with Chrome DevTool or man-in-the-middle techniques. So we must trace back to the payload generation process. So it is a code on the browser, but this code is obfuscated. Okay. So who know obfuscations? Yeah, tell me. Okay. So let me share with you some definitions. So obfuscations is the art of rendering, get it again. Obfuscation is the art of rendering code incomprehensible. You know that. You all have that one colleague who is an expert of obfuscations. Perhaps it's even ourselves. But here, when we are speaking obfuscation, it's a whole new levels. When you are reading obfuscated code, you can barely understand what the code is doing and why it's working. And now the art of the obfuscations is making sense of obfuscated code. And it's not a mirror operations, because it's very challenging to find the way to deobfuscate that. But before we try to deobfuscate code, we need to understand how the code is obfuscated. So let me share with you some techniques of code obfuscations. So first, we need a tool. We need a tool called Babel.js. Who know Babel.js? Some of you. Front-end track? Yeah, please raise your hand. So Babel.js doing minification most of the time, so reducing the size of the code. But what does it do exactly? It takes a string, which is basically your source code, and transform it to an abstract syntax tree. This tree represents your code with function declaration, expression, whatever. Then we apply transformations to this code, like modify the node setting, switching the branch. And believe me, it's far more easier to apply transformation to a tree than to source text. And finally, we use a generator to convert your tree back into source code. So now let's jump into some string operations. We will start with string bracketings. So in many interpreted language, you can access methods and value using object keys. Okay. So this key can be transformed from dot notation to string notations. It stays readable. It's JavaScript. It sucks, huh? Yeah. And we can make it complex. So even it's readable, we can try to apply some harder techniques. It's string splittings. It's like breaking a word like string in SRR and EN. Okay. It is harder to read, but you can still understand what code is doing. So how can we make it harder to understand? We can use constant unfoldings. So instead of using string, we will use random constant group in different places in the code. So when you read the last line in red, you cannot understand the meaning of the operations. But we can still refer to the definition to figure out the actual value. So that's why we will encrypt the value using a functions. This technique is known as string concealing. So in this example, we use a simple base64 encoding. But keep in mind that Antibot system use far more advanced function and a lot of function, and they group that together. So this makes it very hard to understand. So now let's jump to code flow obfuscations. The first technique is known as code flow confusions. So the goal is to exploit all the possibilities of the JavaScript interpreter. Here we can alter the conditions. So normally the condition, if the condition is evaluated to true, the interpreter executes the code block. But we can transform it to a single condition without a code block. So we insert the block inside the conditions. It is more complex to read, but we can still understand that. So that's why we will inject dead code. I love dead code. So both expressions are doing the same stuff. But on the second one, you have code which is unexecuted and useless. It makes it harder to understand. So imagine if we had this in the previous conditions and you had not one line but thousands of characters. It can be very difficult to understand where is the real executed code. And we can combine with scope confusions. So the idea is very, very simple. Just name everything A. And if there is a scope collision, use B, perhaps C. So you can rename a variable, method, class, whatever. And in this example, we change valid to B. So we also introduce a new B inside the code block. So in the code block, which B are we referring? It is pretty confusing, especially if you have 10 variables. And I love the last one. It's probably the sneakiest method out there. So what is control flow flattening? The objective here is to convert sequential code into a state machine. So it's like you go back in the old time and use 2 points everywhere. So you have go-to point on your old code. And you will end up with a single state machine for all your functions. It turns debugging into a nightmare. You cannot follow the instruction anymore. It's very complex with control flow flattening. I won't go into the obfuscations. The basic stuff is to find the right sequence of techniques, and you have to try the fine approach. But now let's say that we successfully deobfuscate the code. So we are the king of the world. We need now to identify which signals are used in the payload. And there is 5 types of signals. So the first set of signals is about configuration details. So this includes browser setting, OS configurations, and whatever events. So we already discussed about this aspect previously. The second set of signals is about automation detection. I told you about that with Puppeteer Seleniums. Because this kind of tool, like also Brave browser, can introduce JavaScript objects for iterations. And Antibot system love to check this kind of signals because it's red flag for automations. The third set of signals focus on graphic rendering. So this involves drawing a graphic in a hidden canvas or offline canvas and get a buffer hashes. It's important to know that the rendering depends on 3 components. First, it's the browser. Second, is the operating system. And third is the GPU. For example, if you are rendering emoji on Windows and Linux, so if you have a dual boot, same machine, same GPU, same driver perhaps, you will have different rendering because the emoji style is different. Also, if you are using the same OS, same material, same GPU, and different browser, the hashes will be different. Also, if you activate or not the GPU, hashes will be different. And if you check consistency between the declared GPU, you know, from the model configuration and from the hashes, you can be surprised. The fourth set of signals try to counteract reverse engineering. So a common technique in JavaScript is to get the code of a native function. So if you print the code here of query query selector. So you're not executing query selector, but you get the toString of query selector. You get two keywords, native code. But if you try to monkey patch that with polyfill perhaps, which is common techniques, you will no longer have the native code keywords. You evaluate something instead. And that's how Antibot system detects that you are trying to emulate some hardware. And the last set of signal is mostly integrity control is checksums. So if you are modifying some value, don't forget to modify the checksums. So that's all for the signals. I will also want to spotlight some next stuff in terms of protections. So this is our techniques that you will find in the coming months, or perhaps some commercial systems are already using them. So let's get back to the deobfuscation techniques. So when you want to deobfuscate the code, you have the code on V8 runnings, you deobfuscate the code, and you have the resource code. Okay, that's easy. So now they are adding a new layer, which is the virtual machine. You all know what is a JVM, yeah? We're good to go, okay. No, not only, yeah, raise your hand, I want to be sure. Okay. So the virtual machine executes bytecode, and the bytecode is the source code. So now when you deobfuscate the code, you will get the virtual machine source code and the bytecode. But this time the bytecode is proprietary and undocumented, so you cannot understand what the code is doing, and translating from bytecode to real source code is a nightmare. So I hope that you enjoy the sessions. Here are some open source tools if you want to do some reverse engineering. So thank you very much. Download Scrapoxy, and that's it.